off screen so I can easily do that. So let me share my screen quickly and we start. And we much of the work we're going to do today is data visualization. Let me admit that this is not what I mean by data visualization. I just want us to have a sneak peek of how data visualization is going to look like, because the next part of the work that we're going to be doing will be real work. We'll be doing something on survival analysis. I have some data from cancer, and then we would like to look at like breast cancer. How do we analyze it? The survival analysis. If somebody has it, and there are other parameters there, how are we going to know whether the person will make it or will not make it? And at what point is the person likely to, to have it reach a particular peak? So is we'll do that one. We'll look at modeling. We'll look at different actions. So we'll look at regression. We'll look at what is it, random forest and whatsoever. Then they will come with some of these small plots. And if we don't do these plots ahead of time, that's going to be a problem. And that's why today I want to combine so many things and then we do it at the same time. All right. So I'm just sharing my screen right now. Is my screen visible?
Yes, it is.
Paulina, can you see my screen clear?
Yes, it is.
Great. So first of all, we want to look at packages in R. So let me pull this. I think that all of you, if you are watching, please check if you want to select some of these windows. At each plus, it tells you that you can move in either direction. So when you press your mouse, the left button down, you can just drag it up and down the way you want. Because I'm doing this because most of the packages, when we run them, they'll tell the margins are small. It tells you that the window that you're supposed to see the results is quite small, and you need to widen it up before the thing can appear. So that's what I'm just trying to do. At this point, we don't actually need the environment, but we may need it quite pretty soon. So I'm going to be sliding the wheels whilst I do the. So first of all, we want to look at packages and how do we install packages. How do we install packages in R? It's very important. So a package is simply a set of functions that has been written together. We've already looked at functions. The assignment I gave, I've already solved the assignment is here. They are all here. So we can, I'll make that available when we finished. But there are a series of functions people have written, put together to form a package. Like the last time I said, if you look at something like, if I put a data and I put this small bracket by it, it will bring out all the data sets that are inbuilt and are found within R. The same way, if I should have something like dplyr, as you can see it here, is a package that is found within R. I can install it and then use it for something that I want to use it. I can what a tidyverse, and then there are about 18,000 packages. And because R cannot have all of them on your computer, we can't have all of them at the same time. So as and when we need each of them, we will install that one and then we use it. Now, there are several ways of installing a package. The easiest, before you can install a package, it's important to know whether that package is found within the computer or not, or is found within the R version that you are using or not. How do we do that? You can just type dots and you say library paths, and then when you put this small uh, 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 open and close bracket, really the pages are actually like it can give me the direction to my computer where I could find the so that window and it give you the pathway to whatever that you are supposed to look for. Now, if I come and I want to see whether a particular package is there or not, first of all, you do library and then open and close this bracket. When you run it, then it's going to pull up all the libraries or most of the packages that are within. Some of them may not be within this R package, but we can install it with what we call the CRAN, and then to install that. I'm going to be doing that quite well in a moment. So these are the packages. So imagine maybe I wanted a package on SAS. I wanted a package on any of this, like the soya bean something something, and you see the package name and then the package description. You can try that on your computer and you will see that. So like ask pass, it's a safe path, a password entry for R. Like it's a whole package having a data and whatsoever, like baby names. So if you want to use that particular package, or if you want to use a data set that comes with that package, unless you pick that package and install it, you'll be able to have access to the data set. I actually have a data set that I intend to use. It's about the life expectancy of Africans. No, of continental life expectancy. We want to compare Africa to other continents and see where life expectancy is high or low and whatsoever. So it comes with a different package. So we need to know how to install the packages before we can go ahead to be able to have access to whatever that we are talking. So when we do that, one of the ways to install a package is to say install.packages, and then you have into bracket the package name. So let's say that I wanted to install a package. I could just say install. You see that by the time I finish is install.packages, then I put my double quote inside and write the name of that particular package. So let's say one of the packages that we just looked at right now, one of them, let's say, is like the baby names. Let me just copy the baby names here. If I come, I can just put it in between this one like this, and then when you run it, it will start installing. So when you check in your console, you can see a red button that is stop. It means that when you are installing the package and on the way, you don't need it any longer. You can just say stop, and then it will stop, and then it will stop but if you want to install it, you can go ahead and then install it. You see that now it has started installing, and then you would watch it. When it is finished, it will tell you that it has been successfully offloaded, and then it means that package is now available for usage. Whatever data that is there, you can now use it, and then you can have some of them. Some packages are already inbuilt; they come with the R, so you don't need to install any package. But these ones that I am talking about, those ones are people who have used those data to build that particular package, and they have decided to make that data come along with their package. In fact, let me say this: nobody wants to develop a package and wouldn't want people to use it. So what they do is, if I get a data set and I use that data set to develop my own package, I'll make sure that that data set comes with that package. If not, people will go and pick my data set and they will not use my package, and I'll not make money. So they make sure that the two come together. It's like those who design computer virus. They are the same people who design antivirus. So when your computer get the virus, you always buy the antivirus. How will they make money? That's how they do it. So now you see, it's successfully, they'll tell you that package by the names is baby names successfully unpacked, and then everything has been stamped up, checked. So the package has been installed like that. You can now go ahead and and use it. For instance, if I now come down here, maybe if I say baby names, you see that it comes already. If I say baby names, it comes already. I could just give it, let's say I have this, or I could just say I want to look at the structure, or yeah, let's say the structure of baby names. Let me close it. Maybe I need to put it in quotes, I'm sure. Or maybe I'm supposed to load it. Yeah. Yeah. I'm supposed to load it first. I think I should have said that before. Now, when you have finished installing a package, it means that the package is now found within your computer. But the package has not been loaded in our environment. To be able to load a package, we do something we call library. The library means to load the package, and you put into bracket the name of that particular package. So into bracket, I'm going to say baby names. You see, that comes there. So now it has been loaded into our packages. So now let me come here and try again and see. Let me see, like I want to look at the structure of baby names. That should be coming. So now when you fold it up, can you see the structure of the data set? You see the data set is there. Today, I beg you, I want us to be doing most of the things practically. So up to this point, I'm going to pause there, and I'm going to give you some few seconds to do exactly what I have done. So first of all, do dot library path. Is somebody talking? So after that, you library on your on your computer. Oh, that's going to take a long time because we have a lot of things to do. So no, but this part is very important. It is. So you guys just try this. I want you to try and check on your computer where are your your libraries or your packages are likely to be found. So it's kind of like you want to know the directory in which you are working. So when you install packages, or if you want to install packages directly from somewhere on your computer, where is the path, the full path to that? To be able to get the full path, you do dot lib paths, and then you put this open and close bracket. It will tell you in your computer where is the full path to your libraries, or where is the full path to where your R is installed. Then you can do that right now. Then again, when you finished, come and do library, ordinary library, open and close bracket, and then tell me how many libraries you have. Then try and use install.packages to install one of them, one of the packages that you have library that you have seen. And after that, load it onto your computer. To load it means you say library into bracket the name of that particular package. And after that, look at the structure of that data set that comes with that package. And then, straight away, I will know what has happened. I hope that's...
I tried doing that. The library, I had an error in file.
Is it the library?
Yes.
You wanted to know the libraries you have.
Yes.
You wanted to know the packages you have.
The library.
I say, well, you do library, open and close bracket. Have you done that?
I ran that, and then they said cannot open the connection.
It cannot open
Connection.
Read the entire error and let me see.
Error in file. Into brackets. Let me just snap and then send it to you on WhatsApp.
Okay. All right then.
Please,
So the rest.
I would suggest we take it step by step.
All right. So then let's do it this way. First of all,
Because
All
the
of us,
first
let's look.
one, you said we should do
The first one,
dot.
do
Yeah, you
dot.
said we should do dot live paths.
Yeah.
But when I did it, I didn't get any feedback.
Did you check in your console?
Yes.
And then there's nothing there.
Yes, there's nothing.
Okay, in my console, I have something here.
Yeah. What do you have?
So I have
and open
C
column /
colon / users
that's all. It's okay.
app data local. Okay.
It will end with 4.2, right?
In my console, yes.
Yeah. Then that is it. I expect the rest of you to get the same thing. Check how you you have made a space. Maybe there's a space between the dot and then the L.
You are referring to installing package into C.
Yeah. Then the next
okay.
one.
I got it.
Is it okay?
It's okay.
Okay. Then the next step. Now let's.
Okay.
Okay. The next step. Let's do library open and close bracket. Let's see. When you run that, you should get plenty packages.
Yes. I got the packages.
All right.
Yeah.
But now, how do I close it? Because
now just look at that one will appear on the right hand side of the script you were working on. The script you saved it. Just look on top. I mean, can you see my screen?
Yes, I can see.
So have you seen that I have opened? This is where it is open. That's where yours is. At the back of it.
Add packages.
And when you look on top, have you seen it?
I've seen it.
If you look on top, okay. Well, they are like links. So when you click,
close it from there.
No, okay. Now the next thing to do is just pick one of the packages. You see their names and their description. So just pick one of the packages and install it, and let me see. So you will say install.packages into open and close bracket, and then in double quotes you put the name of that package and run it, and let's see what will happen. But if you don't have plenty data, please then just skip that place, because it's going to take your data to install. Let me check this quickly.
It says that a version of this package for a version of R might be available elsewhere.
Yes. So it means what is it means the version you are using what does not support that package. You see, or what is it? You see, so you look for a different one and try that, and let's see.
Okay.
After that, I will show all of us how to be able to install those type of packages.
But I want to get the situation where we are getting the baby names. Is it from the is that I have to put in
so if you are watching my
want to download
screen,
because in my R package I've realized I have base, boot, star, and the rest.
What is it? One bracket. Yeah, it will come down like this. So I just came and copied the baby names here. I just copied the baby name there. Then I move away from that link and I came and click on the script link. All the links that are having R script, it ends with .r. When you see anything that doesn't end with .r, it's not a script. On the link bar, you see, R has a link bar on top there. So you always remember to click that. So when I come, I want to say install.packages. Then I open and close bracket. Then in double quote, you put the name of that particular package. And here it is baby names. So when you finish like that and then you run, it will install the package. I'm trying to address another issue from.
Okay, I have another issue.
Okay. So Paulina, I've seen where the issue is. That's not where you're supposed to put the dot. The dot is for you to find out the path. The dot is dot lib paths. But for the library, you don't put any dot at the back.
I didn't put any dots at the back of the library.
Okay. Yeah.
I didn't put any dot.
Include brackets. That one is to only tell you the directory, the full path. I think is the name full path that might be the full path is. We will get to know these things when we are doing Linux. That's why we have full path to know exactly where I can go and find a file. So we say
Hello?
the full path. Hello? Yes.
Please, can I raise my issue?
Yeah. Raise it, please.
I tried installing the package called base. And the feedback I got was that one or more of the packages to be updated are currently loaded. Restarting R prior to install is highly recommended. RStudio can restart R before installing the requested packages. All work and data will be preserved during restart. Do you want to restart R prior to install?
It would.
Should I go on? Okay.
If you agree, it's going to. Okay. Then just try the baby names. Just try the baby names.
I've already clicked on the yes.
You can just.
It has appeared again.
Okay, then. It has appeared again. It has what? It has it appeared again?
It has appeared again. The same. Yeah, the same feedback. Updating loaded packages.
It has appeared again. The same. Okay, now it's updating loaded packages.
Yeah.
The same feedback.
Yeah. So Eben, what about you? Paulina, have you sorted the issue out?
The dot, it's not.
You are supposed to use the dot when you want to load it.
No, it's not. I use the dot. I use the dot. When you check my console I sent to you.
Yeah.
You could see that the dot.
The console you sent to me.
It ran. The dot library path. It ran.
Yeah, and that's what I was saying. Now, but when you went to the main library.
Yeah.
Okay. When you went to the main library, the first one there was dot. The second one there was no dot, and then there was an error. In addition, warning message. Okay. No, what is it? It's like you clicked. Write it again. Paulina, do library again, and then open and close bracket. What is it? It will work properly.
It's the same issue I'm getting. Cannot open the connection.
Which version of R are you using?
It's the one Eben is before. When you check, because open is the 4.2.
Dot 2.
Yeah.
And you mean you can load? Have you put any space between the library? Because when you start typing library, by the time you finished, the library should just come up. So click on enter.
Yeah.
Like
That's
if
what
you
happens.
do library, you should just do enter. So don't do anything else and go and run.
That's what happens. I don't know. The other day I saw something of this sort. But I don't know why today it's not working. So I tried installing cars as a package, and they say cannot open the connection, cannot store. And I tried installing the baby names. It is similar message I received.
Did you use install.packages?
Yes.
I mean, if you are watching my screen, then like for instance, no,
sometime back I was installing packages just by going to the package on the left lower down side.
Yeah.
Then I just go through and click and automatically install.
Yes, I was coming. Yeah, yeah, I was going to come to that. Okay, then try that one and let's see whether if. But I'm surprised that your library is not loading the libraries you have. That's my bigger worry, not the packages. Library, there you have open and close. Is there another person who has that issue? See, the gentleman.
Hello.
Yeah, hello.
I don't know what her issue is, but you know, I raised a concern with you.
Okay. I was thinking that maybe if you do library open and close, it should be able to bring out. Okay.
Later on.
Okay. So no. The thing is, if I don't get it sorted, downside you're going to have a problem following the tutorial, or you won't be able to practice at all.
Yeah.
So now you come to your console, then come and do the library there and let me see something.
Okay.
Come to the console and then just type library open and close bracket.
It's the same message. Don't worry.
Okay. Eben is saying that his network is worrying him. Let me try and see if he's back. Okay. So now, what is it? If you have installed any of the packages I just mentioned, you can come and look at the structure. So you just like the way we look at the structure of any data, you say str into bracket the name of that package. Hello.
I'm not able to.
You are not able to install the package.
Hello.
Yes. Hello.
Please, I'm not able to install.
The baby names. Okay, install the baby names and let me see.
I'm not able to install. Yeah. The feedback I get is that one or more of the packages to be updated are currently loaded. So restarting R prior to install is highly recommended. I said yes. Then it will go and the same feedback will appear.
Okay, so let's. I mean, read the code.
Not just baby names. I use base. There's a package called base.
I also use base, but it didn't run. But when I just did baby names, I saw that it's running.
The network is not allowing me. Hello?
Okay, then I mean that's what I wanted you to try. That's what I'm saying, that not all the packages are compatible with the current version you might be using. And that one you use CRAN to be able
I
to
tried
install
baby
them.
name, but okay, let me try it again.
Okay.
The feedback is that. Hello?
Yeah, hello.
Please, can you hear me?
Yes, please. I can hear you. I can hear you loud and clear.
With my office laptop,
I can hear you. Go ahead. Come again.
With my office laptop, I'm able to.
Okay. Then
But that one is using an old version than what my personal laptop was.
Oh, okay. I think there might be some. I think that maybe at a point we have to save all that we have, take all those R versions out, and then install completely new versions. So that in R, whatever we are doing, when you take it out and you install new one, you won't lose anything. Everything is still there. So have you been able to install the baby names? That package?
Baby name is still downloading for me, Eben.
Your network is is too slow. That's why I didn't want to, but I just wanted you to have a feel, because I can tell you that as we go along, almost every single time you have to be installing packages. You have to be installing packages and librarying them, because if before you finish analyzing your data, you would have installed like more than 20 different packages. For now, if we are going to generate a proper graph, we need to install a package like dplyr. You want to, deal with like this thing I'm talking about. That's, I intend to be like an assignment. That package that comes with the data set on life expectancy across the world. If we are going to do, okay, so can we go ahead?
Yeah, since you have the recorded version, you can look back and wait without making progress.
Okay. All right. So when you finish installing any package, the next thing to do is to library it. Library means to load it onto your computer program, so that R will be aware of it, that this package is being used. So to library, just say library into bracket the name of it. After that, you cannot check the structure like I've done the structure of it, and then that's all. It will tell you that, hey, that particular data is actually in the form of a table, and then you have different dimensions of it, and then what is it? That is it. If you want to know much more about it, you can check the dimensions. You say dim and put baby names, and then just run it. It's actually a data frame. All right, and you can see the rows are too many and the columns are only 5. So to check, let's say the class, let's look at the class of it, of baby names. We can say that it is a data frame. As you can see it here, it's a data frame. Obviously, when you have seen the table, you would have a prior knowledge that is a data frame. All right, so that's one way of installing a package and looking into it. The other way to install a package is to go to the right hand side, the bottom window where we have packages. You see files, plots, packages, help, view, and whatsoever. When you click on packages, you will see install. And then click on install. This small pop-up menu will come up. Then just type the name of the package you want to install in it. If that package is already found within what you are doing, then it will simply tell you that the package is there. If not, it means you won't be able to install that package. For instance, if I start typing, let's say, baby names, you see that the baby names will come. There are two sets of them. We have baby names and then baby names IL. Two different ones, but we are looking for baby names. If I click on baby names here, I come and click on install, it will go ahead and then install it. If I don't want it, I just click this. So that's the second way through which you can install a package. The third way is by using the CRAN. If I want to go to that, we won't go anywhere today because of the network issues. Because the CRAN, you are actually installing from an external source. So what I'll do is I will add it as a link and the steps when we finish, and then you can just try that. You can leave the computer and then it will start installing as many as you want. You can leave it the computer run the whole night while you go to sleep so that it will do that for you. Now, when you have finished installing, one of the ways to load the data, like I've already said, is by a library. You put the name of the package into bracket and run it. Another way to do that is by clicking packages on the right bottom window, and then when you do that, you will see all the packages you have on your computer. It will display. You can just check whatever package that you want to load it. Once you have installed it, go and click on the check box. It is another way of saying that you have loaded it. So when you click on the checkbox, you have updated it. If you want to remove it, you go and unclick over there. Even though it will not be removed from the computer, but it will not be within our environment. Because some of the packages, they interfere. If you have that package, it may mask the performance of another package. So sometimes you deactivate some, but the interesting thing is that R will do that automatically for you. And then you don't have to worry yourself about it. Just that we just have to know about that. Now, that's it. That's a little bit
so
about
something. I noticed something here.
Yeah.
So initially we were trying to download Base.
Yeah.
But I realized that when I went to packages, it has already been ticked. As well as the baby names. They've all been ticked.
So it means you didn't have to install that again. That's another. Thank you for for redirecting us. That's another way to also check to know that if you are installing a package and it's telling you that it already exists. Like Mohammed, if you are listening, maybe you could check that to see. Mohammed, if you are listening, please try and check to see if when you click on packages, all the packages that you have on your computer, check on just go through them and check whether baby names has been ticked.
Base has already been ticked.
So it means you don't have to.
I can't see baby names.
Oh, baby names is just two steps above, just on top of base.
I don't have it.
So
that means
it's not installed.
Myself and Mohammed, we are having the same issue. We also have the base.
Yeah, it means so. It means you haven't installed it. You have not installed it. Yeah. So it means we have to. Don't worry yourself. We are not going to. That data set is really large. It's millions. It's about 1.9 million.
Okay.
Yeah. So maybe we may use that data if we are to build a model like larger data sets. So okay, now let's go quickly and look at something briefly about package factors. factors. Now, if we can install our packages, we know how to load them and how to search for them in the first place, to install them and then load them. I think that will maybe fine. So let's look at packages, factors in R. Factors. The reason why I'm doing this is that I escaped my mind to have said this quite earlier. It's not all the, most of the data set that come, they are categorical. Naturally, we should have started by discussing types of data, what are the different ways that we look at data, ordinal data, cardinal, those time series data, and whatsoever. But I thought that we can do that when we are doing data visualization. Now, factors is one of the ways through which we handle data. A factor is, we use factors to be able to know how many times something has appeared. You see, for instance, if I have, let's say, a data set, I'm just going to create a data set here, and then I'll just call it, let's say I have, okay, 1, 2, 3, 4, 1, 3, 4, 1, this. Then, like, when I have this kind of data set, maybe you all know that sometimes when you go to pick a data, okay, if you go to pick data set or a data from any environment, you could come there and you want to know maybe how many people were recorded 1, how many people were ticked as 2. For instance, you are saying that, okay, if the person is a male, he should be ticked 1. If it's a female, if the person is a female, he should be ticked 1. I learned this when I traveled recently for data science conference. I was told that they say that we should no longer give 1 to men. It's gender bias. So if the ladies are 1, men are 2, children are 3, the aged are 4, and then in that order. Now, when you come to be able to analyze this kind of data, you need to change it into factors. For instance, if I run it now, you see that everything is the same thing, 1, 2, 3, whatsoever. If I print the data, that's going to be 1 to 1 with this and this and this. But how will I know? How will I know how many of the people there are 1s, how many of them are 2s, so that I'll be able to make sense from it. All right. So to do that, you change the data into what we call factors. So that in factors, you cannot check for the level, and they will tell you that level, and they will tell you that, okay, the 1s are 15, the 2s are 20. So you can say that, okay, those who are female in the data set, because obviously you can't go and be writing female, male, young. No. That is if the categories are just few. But if there are many, you won't be able to do that. So let me do one example here. So let me say I have SSS. And then what I'll do is I'll just say factor. So if I put factor there, it's going to ask me of what I want it to be factor. So I have converted whatever that was there as ordinary numbers into factors. Now when I come to run this SSS, you will see that now it will give me the actual data and come and tell me that levels are 1, 2, 3, and 4. Even though the data set is that much, but it has categorized 1, 1 alone, categorized 2, 2 alone, categorized 3, 3 alone, and 4, 4, 4 alone. Now, in that case, if I want to say, let's say I want, let me just put this, and then I can just, okay, let me just plot. I can just put plot there, right? And then I'll just run it and see. So if I do this, now it can give me that, okay, these are my 1s, these are my 2s, these are my 3s, and then these are my 4s. So I can actually count, I can actually do a count here, count my SSS, oh sorry, I wanted to count it, but I've forgotten of how to use it. I wanted to count the levels. I wanted to know the levels. So maybe I could just put the levels, and then I can put S, S, S. Yep. So the levels are 1, 2, 3, and 4, but that's not what I want. I want to know how many are the ones and how many are the twos and how many are the threes and how many are the fours. And that's what I wanted to count them, but I've forgotten how to use it. So I'll go ahead. When I remember it, I'll add it. But that's able to, you can, it's not only in vector form that you can do that. Okay, somebody is out, is asking me to let him in. What is it, Mohammed? He's
in now.
Okay, all right, then.
Okay.
Another person is out. So that's basically how we are able to change a data set into factors. And now when we do that, maybe we may be able to now visualize it, and then we can make sense from it. We can now say that, okay, let's say, I think I should be able to know how to do this, but I'll try and do that later. Now, let's say this is another data that I'm just trying to. So another way of building that, we could use this function called GL. Then I want to have the data that I have on top here, or the names of the people I have here. I could just put this, put my name there. I could just put somebody else's name, and I can just put here this makes sense, and we're going to be using foreign stuff. So just put this GG. So when I do this, I can come and print GG, and then what is it? What the levels are? You have, let's say, you can see that you have my name appearing the number of times, colon appearing different times, root appearing different times. What that means is we are trying to create what is it? These people, their names. So the first one will appear 4 times, the second one will appear 4 times, and then the third one will appear also 4 times. And then what is it? We are able to use factors to be able to know that they are of different levels. For instance, if you also have data like male, female, you are also able to use that one to be able to count how many males are there, how many females are there. So those ones we use factors to be able to do that. And that's why I didn't want to pick it as a topic on its own. It's actually quite small, and you don't have to waste much time on it. It is any time that you are always looking for data to be factors, to be categorical. Like in machine learning, some of the data set you have to convert into categorical data, count them before you are able to build a model or build your neural network around it. Okay, so that's a little bit about factors. I don't know, is there anything that somebody is not clear about factors? It's just, if it was a data frame, you just need to specify that data frame, okay, and then specify that particular column, and then you can come there. You can now come and say, okay, factors. If I don't know if I have any data frame around, I could have just tried one, and then you just let's assume that this was a data frame I have here, so you would simply just use your $sign, then to identify the specific column you want to convert into factors, and then apply the factor function to it. Then it will convert that into factors. So you'll be able to count the levels and know that, okay. The other place you can do that is how many people scored 30%, how many people scored 20%, how many people scored this, and then in that order. After that, you can count that. And then, so just like we were having the baby names, we could have also changed the baby names into factors. For instance, how many were they? Let's say there were 5 columns and then a number of rows. Maybe we are not looking for all the rows. We just want to pick part of the rows. So we could have just say baby names. So we bring the baby names here. But once we know it is a data frame, we can just put a dollar sign. You see that there is sex, there is a year, there is a name, and then there is something N. I don't know what that is, and there is a prop. So we could pick maybe the name there, and then say we want those ones to be factors. So after I have done this, then I come at the back here and apply the factor. What is it? The factor function, and then come and close this up. That's all. So I will pack that into maybe a new variable. So we can say maybe factors of names. And then if I do this, then it means I am changing all the names there into factors. Or perhaps if they were already factors. So when I do that, I'll be able to know that, okay, if there are some names that are repeated, how many times did that name appear? Then I'll be able to, to do that. So that's in let's say, another way we could have done this, to be on the safer part, we could use the curly bracket like this. And then we have our open and close bracket. This side, we're just looking for the first 10 rows. So up to the 10th row. And then we come here. And then we are looking for one of the columns. Column 1, what was column 1? Forgotten of what column 1 is all about. Okay, there was a column called N. 1, 2, 3, 4. Yeah. Or the prop? No. This is something else. There was a column called, that was the 4th column, I think. So I'll put 4. So do that, run it. I cannot data frame or there's a warning message here. They're saying that I cannot xt from data. I don't know what that means. The xt here, I don't know what that means. But I'm sure they're saying that I cannot extract the data frame. Yeah, maybe. I don't know what that means. That's what I was saying. But just know the syntax, that this is how the syntax is supposed to appear. Okay. I'm going to move out of that and now come to what we're supposed to do properly for today. Now, what we're supposed to do properly for today is to just have a feel of how to visualize data. And this one, we all have to follow very strictly. The first part, because we have to be doing it over and over and over, that's why I just brought that up. But those parts were not that serious. So we want to look at how to be able to visualize a lot of data. When we have data, how do we visualize it? How do we look at it? So let's start, all of us, if you are listening, just create any vector of your choice. Create any vector of any length. Don't let it be more than 10. So we can say, you see that I've created a vector here. Let's say 21, 62, something. So let's create a vector. So you can call it, it can be score. Maybe the variable could be scores. So scores, then you just create a vector and just put the, you can put any, you can use any of the random data creation something and create the vector. So I could have 55, maybe 66, maybe 85, maybe 45, 54. So when you finish creating, if you have created the vector, come and create each. If you are dealing with scores, then there might be names of people who have this kind of scores. So you can just say names. The names, you can spell it with Z at the end to make sure you distinguish it from the inbuilt function called names. So now you are going to create names of people. So you have to use double quotes and just write whosoever name that you wish. I am very familiar with my peoples and their names. I could just say the dudes and whatsoever. Are we following? Okay, we are all online.
Yeah.
Great. We have 6 important ways to visualize the data, so we have to be fast. If you have finished, then this is what we are supposed to do. When you run the data part of it, and then you see that you also run the labels. So the first part we want to visualize our data is a pie chart. We want to use a pie chart to visualize our data. So the syntax for the pie chart to visualize data is you must have the vector which becomes the data, and you must have the labels. So the number of entries of the data must be equal to the number of labels. So I have a data here, I call it X, and I have the labels called Tamale. So if I want to represent it in a pie chart form, this was what I was trying to do. Are you guys there?
Yeah.
Yes.
All right, so I beg you, please. Sorry, I have to take you a little bit back. The factors I was saying that if you were having SS and then you were having the whole of this, it couldn't make sense. You couldn't know whether how many times did 1 appear, how many times did 2 appear. And I'm saying the best way to be able to do that is to make sure that you convert the whole thing into what? Factors. When you convert it into factors and then you plot it, this is what you see. I think by our data visualization, that's what we should do first. I beg you, all of you create. So leave the pie chart for now, go on top of the pie chart and then do this. On top of the pie chart and then do this. Create a vector. So you have a vector called what is it? What are we measuring? Paulina, what are we measuring? Where we give numbers. Tell me quick. So that we say 1 represent this.
Height.
Okay, height, they are quantitative, we can measure. But I'm looking at those qualitative data where we can represent them by, okay, let's say that what we are looking for preferences, or we are looking for the kind of data that, okay, let's say.
So we can talk about satisfaction.
Satisfaction, thank you. Because this is it's not easy to be able to measure satisfaction. So we can say those who are satisfied, they are like 1. Those who are not, in that order, all right? So let's say we have a range, we have issued this data out, and people have brought out back whatsoever. And we've noticed that we gave the possible answers as 1 to represent much satisfied. 2 something, 3, and then 4, 5, 5, not satisfied at all. So what we're going to do is that we're going to create a vector of satisfaction. So satisfaction, so that's our variable. We come here, and then because we want to have much of it, much of the data, because I want us to do something, so we are going to use the run if function. So just use the run if function, and then you put the number. Maybe you have interviewed about 500 people, all right? And then the minimum should be 1, and the maximum is what? 5. And the maximum is 5. Okay? But you know, when I do that, some of the data is going to come. So if you run this, hey, they say error, object satis not found. What is that? Yeah, I shifted it. Sorry. So, Paulina, I like the way you are always very fast in identifying where the error is. I think that in data science, you guys, everybody, pay attention to that. Be very fast in identifying where your errors are, and don't be afraid of errors. Errors are always trying to. So now we have it. You can see the satisfactory rate here, but let's run it up. So just come and click inside here and say round. Open it and go and add another bracket over there so that we have just single numbers. Okay, when I run it again, if I come and print satisfaction, so that you see that now I now have only 1 up to 5. 1 up to 5. Do we all have that? When we have that, what we need to do is we have to change it into factors and then visualize it. That's our first data visualization. So how do we do that? Now we change the variable from satisfaction. So I'm going to say I'm now creating a new variable called satisfaction. Then I will go ahead and then go and say that I want to change the original one from ordinary numbers into factors. So I'll put the name of that, which is satis into it. Then I'll pack that into the satis f function. Then when I come, I can now print. So I said print. I can now plot. I can plot it, and then I just need to put satis and f. Now, if all of you have done it, now tell me, has everybody done it?
No, please.
Excuse.
No, please.
Okay, quick. What is it? What is that? I'm serious. I like fruits a lot. I can actually roam like 5 miles to go and look for fruits to buy. If I look for fruits around here and I don't get it, I just take my motor and go to Ejisu. Go and buy. What is it? Thank God we have a doctor in our midst. He knows that fruits are very important. So I know by now he said, okay, that's good. What did they say? We shouldn't chop meat. I don't know. All this money we're gathering, what do you want us to use it for? Say we should chop meat small. Paulina, has it worked?
I'm now doing. I was just
Okay.
Yeah, it does.
Great. So
That's work here too.
okay, then that's great. That's great. That's great. So I'm going to say, I'm going to try something here. Okay, I wanted to add color to it and see what will happen. Color. Colors. Okay, I will even do that later on. Color. Okay, so if that has worked, now we have seen why factors are very important. If not, that data we will not have made sense from it. Now we can say that all those who say they were satisfied. So we see that we cannot look at the graph and then interpret. We cannot say that okay, people who said they were somehow satisfied. Mohammed, are you in? His network has vanished. Oh. Okay. Okay. Then now let's move. Then we come second. Let's create a vector and then labels. Now we're going to do a pie chart. A pie chart takes just two important things. So what are we going to do? We're going to say that okay. What? The syntax is that when you have pie charts, the function is pi. If you go into bracket, you will see this pop-up window that tells you exactly how you are going to put the labels. X is the first one, followed by the labels. The labels, you should have some names whatsoever that you are going to give it to it. So the names can be a vector. You can create a vector already and use it. And then you can also create it within. So here, first thing, let's say, is the data. That's your X, followed by the labels. And so when I come here, I've created my vector already. I call it X. And then my labels, I decided to give them names of like Tamale, Bolgatanga, Wa, Sunyani. Let's say that maybe this is something that represents Tamale. What you should know here is that the number of entries in your data must be equal to your number of labels. And that's how it is. So when I come, if I do pi, I should be able to generate a pie chart. As you can see it over there. Please, let's do this quick. Just create. If typing is too much, you can just put that A, B, C, and that's all. Maybe type 1A, B, and then C. Or you can use the letters. That's why I was doing all those things first. You could just, the labels. I mean, if you are done, just tell me. So we'll move ahead and then. Or do you suggest that I just go through after that? I send you the codes. That is not helping. It's not really good in what in learning basics of data science. The typing helps a lot. I must admit to you, the typing helps a lot. Because if I send, oh, okay, Mohammed is back. So, have you generated the pie chart?
Yes, I have.
Eben?
Oh, please.
Where?
Take it again.
I should take it again.
No, I have a problem here. I think I have an error.
Is it with the pie chart or the factors?
With the pie chart, please.
The pie chart, just create a vector, then come and create the labels, because every pie chart has a label. You want to label, okay, you have different temperatures of people. So if the temperatures are 10, then there must be 10 people. So you just give the names of the people as labels. After that, you come and do your pie charts with the data first, followed by the labels. So when you write pi, open bracket, then the name of the data or the vector that you created, that comes first, followed by the labels. The labels are the names you have given to each. And when you run it, it will generate the pie chart for you. Mohammed, can you try? But the internet has been a problem in Africa.
Hello.
Yeah, hello.
Yeah,
I can hear you.
I tried creating a pie chart, but
What happened?
it doesn't look nice because of the vector. The vector I used. You know,
Okay,
the vector I made it 1 to 8. Then the labels,
What is it?
they are just names.
Okay. I mean, you can use the.
So it just 1:1.
Okay.
So
Then use much more categorical data. And once you are doing that, if all of you are listening, the easiest way to the kind of data that you put on pie chart are mostly integers. And integers are mostly representing their kind of categorical data. For instance, age. So the ages of people. So you could have something like, what is it? We don't have 24 point this. It's in some, if you want to do 24 point something, then you just count months. How many months are there? I did a video on data entry errors, and right after that, I got quite a number of people contacting me for that. I mean, we enter data, you pick some data, they will tell you that 1.5 months. 1.5 years. Why? So some will say 1 year, 2 months. Yes, the data must have unit. And then you go by the unit. So wherever is supposed to be more than 1, then either 1.2, 1.3. So mostly pie charts are good for categorical data like age, 22, 23, like something like categories of things. They are always good for pie chart, categorical data. Now, so when you create, if you create something like the one I have here, you put your labels, you come and do pie charts. That's all. You are able to. But you see that the pie chart I have created, there isn't any much information on it, right? You just see Bolgatanga, Tamale, Wa, Sunyani. There isn't much information. It means we need to add some information to it. For instance, we must have a legend. We must have a title. Now, in data visualization, anytime you see main, it means we are talking about a title, the title of the graph. All right. Pie chart, you don't need Y label and then X label. No, you don't need that. It's in different graphic that you what you need. I will get to that. So to be able to do that, yes, please.
I've not been able to get my pie chart.
Wait. Let's do it one by one. Create a vector.
Let him read the arrow.
Okay. Read the arrow. Let me see.
There's no error showing here, but let me see if I can show my screen.
Wait. When you go to the console, something should be showing. There's no error. If there's no error,
console, there's no error.
There's no error, right? But you cannot see the pie chart.
Yes, please.
It has run, but you cannot see the pie chart. Is that
yes,
it?
Please. Yes, please.
Then it's hiding. It's hiding somewhere.
Yes, please. Yes, please.
So look below your computer. It means that you have zoomed. When you do something like this, and then
that's
you now
mine. That's my computer. This thing we're looking at.
Come again.
You will on my screen.
Okay. So it runs all right, but the pie chart is not showing.
Yes.
The pie chart is hiding somewhere. Let me show you how to get it.
Yes.
All right, then it's okay.
Okay.
Yeah, it's okay. So it means that you have zoomed a particular graph and you have not closed it. So for instance, if you zoom graph like this, or when you come here, you see that something is hiding somewhere. So go and point your mouse to your arrow and see how many windows appear at the taskbar down there.
Okay. Two windows. Okay, I've seen it now.
So that's why it is hiding. We want to close that place. Close the other one, not the other one.
Okay. Yeah, I've seen it now. I've seen it.
Okay, then great. So now this pie chart that we have created is without any information. So I was saying that after you have created a pie chart, the next thing to do is to make sure that you add what we call main. So I could say main. The main is going to give you the opportunity. You see that is equal to. Then you indicate the title of the pie chart. So let's say the title of the pie chart is kilometers. So when I do this alone, if I run it again, you see that now the pie chart now has a title called kilometers. I mean, let's all add that quickly. I want us to be doing these things one by one. It's going to help us a lot to build and to just run the. Because when we do this, the next one, I'm going to run them through, and then you'll be able to get it quickly. So now we have the main. The next thing we want to do is we could add the color. We can add color to it. And here I need to also explain. Now, when we do color like this, now we can say that there are some inbuilt colors in R. One of them is rainbow. So if I say I want the rainbow color, the rainbow color will come, but the rainbow color will ask me, rainbow has so many colors, so many of them. So how many of the rainbow colors do I want to choose? All right. So I will simply say that it should be according to the length of X, according to the length of the data variables. So if the data variables are 20, choose 20 colors from the rainbow. Okay. So just put here the length of the, so you here you just put length. By the time you finished typing length, it should tell you what length of the variable called x. So when you do that again, now come around you see that now the color of the pie chart changes. It appears somebody is out. Yeah. Somebody is out. Paulina, has it worked?
Yeah.
Great. Now, the very last part of it that we need to do is to add a legend. Now, to add a legend, the legend is, you use the function called legend. Okay? You just use the function called legend, and that's all. So with the legend, you have to indicate which parts of your chart do you want the legends to appear. Is it top right, top left, bottom right, bottom left, or center? Any of them. And now the legend, what do you want the legend to be made of? It should be made of Tamale, Bolgatanga, because those are the descriptions. The legend should say that, okay, when you see yellow, it means Tamale. When you see blue, it means Bolgatanga or something. So when you add legend to it, then it will just work. What is it? And this is how we add legend. I think I should just run the entire thing again. I have a little error. Let me see where the error is coming from. I have my pie charts, labels. Okay, then I'm leaving this portion out. That's why I needed to add percentages, because I've not calculated the percentages. So I'm going to comment that portion out, and then I'll come and run only this line. So now you can see that the pie chart now has a legend. Okay. When this is happening, close it. Just remove the entire what is it? I am removing the, okay. So what I'm going to come again.
Legend side.
Yep.
What happens after the name? You now come down and write the field. Rainbow. I didn't see the other side of
okay.
it.
So this is the legend. So the legend, you have top right, and then even when you put the word legend, the syntax for everything you are supposed to put will come. So if I come here, if I run the pie chart this way, if I run it, then it comes. If I come and run the legends here, but this time around, the legends come to appear on top. Maybe if I wanted it to be top or right bottom, I'll change where it's supposed to be, and then that's all. It will simply appear just like the way I wanted it to be. Now, if you have, come again. You're having issues with the legend?
Yeah.
Okay, I'm saying that, okay, this is where we started from, to the labels, to the pie chart. Right after the pie charts, the next thing you need to follow with is legend. So I could actually come here, and add a legend to it. So if I say legend, So the legend will tell you that you need to indicate the first parts where you want the legend to appear. So maybe you want it to be bottom right. Come out of it, you must indicate what is going to form your legend, and it has to come in the form of a vector. So you can use your C. Just copy whatever is part of the label here. That's all. And then I'm just going to come there and place it, remove the C here, and that's going to form what is going to form my legend. Then I put comma by it. The sex is always the sizes. The sizes. Anytime you have size, so you can indicate like 0.5. That's all. Then the fill could have like, let's say, like a rainbow. But so the fill should be according to the fill you are already having the colors, because you can't give different colors to the legend and different colors to the chart. When you do that, the chart will not know, okay, which color should I link to which particular category. So you always say fill. The fill will be the same as, and this is the appropriate place to enter. So the fill will be equal to the same thing you have filled already. So you just say the rainbow, or you just have your rainbow, and then the rainbow, you are looking at the length, which is according to the data point, which is X. When you do that, now let me widen this up before I start running. Then I'm going to remove these charts. Remove it again. Right. So now I can now just run my first one, my vector. Then I'll run my labels, do my charts, then add my legend, and that's all. Then the chart is ready for me to do whatever I want.
I don't know
That's
why
basically
my legends are not working.
What, is there an error?
It didn't show. It didn't show.
Are you sure you have not zoomed something up and have not closed it, or the plot window, the window where the plots are supposed to appear, if it's too small, it won't appear. That's why I always widen it before I run, and then narrow it up. If I want to run, I widen it up, run it after that. If not, it won't appear.
I run the
Come again. Is it working? Is it working?
They're giving me error.
What's the error? Where's the error?
The error, unexpected symbol in, then they brought the legend, the whole code that comes. So I think the error from the legend code.
Let me take this out. So you have your vector, you have your labels. You have created the two of them separately. Then you come.
Yes.
This one too is also separate. First of all, you have your pi. You start with your vectors, your labels. Main, you want it to be kilometers. Color, you say it is rainbow color, but you just want to choose some few colors. That will be according to the length of the vector, which is your data. Okay, then you now want to add legend. When you do your legend, the first thing that comes is where you want the legend to be placed. Identify that place. That place is a text, so it has to be in double quotes, comma, followed by what is going to form the component of the legend. So that's the data descriptors. Tamale, Bogatanga, Wa, Sunyani. So, and because they are text and they are more than one, you have to use a vector to combine all of them, the combine sign to combine all of them. That's the component of your legend. And you are asking yourself, the legend, do I want it to be big or I want it to be small, small? So that's what you put sex there. The sex tells you the sizes of the legend. You want it to be 0.5. And the legend, what color are you going to fill the legend? Saying that you cannot fill the legend any other. So you use rainbow color. So you also use the same rainbow color. The length of that rainbow color, it should be on, it should just be, because the legend is describing the chart. So when you do this, all of them separated by a comma, comma, it should run. Check it again. It should be able to run. And before you start running, make sure you widen up that bottom right window where the plot is supposed to appear. If you don't widen it up, it will not appear.
I don't know if Paulina is facing the same
Even
thing.
what is
I
legend?
realize
don't know if Paulina is facing the same thing. I realize
when you look at the legend, the last
when you look at the legend, the last
the brackets,
the
you see that there's a space
Yeah.
between the last two brackets.
the last two brackets.
But when I was writing mine, the
But
space
when I
was closed, and when I ran it, it was giving me
when I
error.
ran it, it was giving me error.
But when I separated it, I
which
had
place?
the
When I
results.
separated it, I had the results.
Which place is that?
Legend, when we have the legend,
when we
the
have
last
the last
three brackets, the one
the
closing.
one closing.
Okay, the bracket.
Yes, there's a
Yes,
space,
there's a
the last space
space
between the two.
between the two.
Okay.
I realized when it was
realized when
closed, it was giving me error, but when I
but when I
opened
opened
it,
it,
it went.
It went.
Okay. But maybe you could try that and let's see.
Let's go later on. I'll check because I don't know where the issue is coming from.
Okay.
I've done what Eden said. So let's just continue. Next one, I will.
Okay. All right. So I think we should do. I mean, quite a number of them. So this time around, don't just follow. Don't, because I'll send you the course. Now, if you are going to do a bar plot, that bar plot and pie chart are almost the same. You have to create your vector first, and you also create your labels. The data must have labels. Let's say these are different markets, and then the data set is the vector. So the vector H here, and then the markets here. So you just say bar plot, then you put H here. That one, it will just create only the bar plot without any label. That's it. So if I run H, then without running the label, or if I run the label self, but if I come and just say I want the bar plot of H, it will give me bar plot without any label. So I'll not know which bar represents who. So to be able to do that, I need to have the names argument which is coming. And the names argument, I've already created the names as a vector and given it to the vector called M. So I have, first of all, my data, followed by the argument, the names argument, which I have created a vector, so I just give it to it. But this is a bar graph. So that one has the Y label, the X label. So that's the Y axis like we used to do in transformation. Then the X axis. Then when I finish with that, the main is always it's always a title. So let's say this is a revenue chart in different markets. So the border is not even necessary. If you don't add the border, it's not. The color, I just indicated blue. You can indicate red or yellow or whatsoever. And that's it. The color, if I'd wanted, I could say the color should be rainbow. But if it's rainbow, it should be according to just like the way we have for the. And so if I start running from here again, and then if I come here, you see that the chart will change into. These are the borders. You can see the red borders there. They are not actually necessary. So now you can see I have Najong market, Bongo market, Bintiri market, and in that order. You can zoom it to see it properly and whatsoever. So that's how it is for bar plot. But this same bar plot, it's not everybody that understands the same uniform colors. You could actually want to have different colors to represent different a bar plot. Now this is the ordinary bar plot. So there's another one we call the stack bar plot. I like using stack bar plot a lot. And if you are into microbiome studies, stack bar plots are very important to be able to know intradiversity and interdiversity. So to be able to create a stack bar plot, first of all, you need to know that stack bar plot is created from a matrix data. Matrix data. So first of all, I need to create my matrix. And as you can see, I've created my matrix here. So I'm going to put it there. I'm going to say that, okay, we are creating a stack bar plot. Okay. I like stack bar plots a lot because it's very easy to interpret. Stack bar plots. So what I need to do first is to create stack bar plots are created with matrix data. You see the reason why we were doing all those things earlier. So if you have your data and you want to have a stack bar plot to visualize it, you must make sure that the data is being converted into matrix. Now, when you have created the matrix, you should know that the number of rows, if the number of rows are 3, then it means you are going to describe your stack bar plot 3 ways. It means that every bar will have 3 divisions. Please get this portion very well. If your number of rows of your matrix data, which you are going to use to create your stack bar plot, if the rows are 3, it means that each bar will have different sections, 3 different sections. So because of that, the number of colors for each section should also be 3. That's why I've created a color here, green, orange, and then brown. Then this is the description to your data. And then this particular description should be according to the number of columns. The number of columns. So the number of columns are 5. So I have to start with 1, 2, 3, 4, 5. March, April, that's months. And then regions. The regions. So the regions must also be according to the number of rows. So in each particular region, we are looking at rainfall pattern. In each particular region. So if you have finished describing or coming out with everything you have here, then you can now go ahead and do your stack bar plot. It is not different from bar plot itself, but you will see the difference here. So you also start with, first of all, your values, which is the vector you have created using the matrix. Then followed by your main, that's the title. The title is always it depends on you. So I can just type here, let's say something like rainfall. Then names. So the names are usually the months I have already created here. Then the X level, sorry. And then you have your Y level. Hi. Sorry. I think that the lightning is too much. That is why I'm sneezing like that. In anything you are putting in double quote, when you write anything, it doesn't matter. And then your colors too, you just say according to colors. Colors is also an inbuilt function for colors. If you finish with that one, then you are good to go. So I can now run everything, and it runs. So when I come to the bar plot, I have to widen this place up before I run that line. So you can see how the bar plot looks like. Quite beautiful. So here I have March, April, May, June, July. And this is the rainfall pattern. So I can see that this particular color, what does it represent? For now, let's go back and add the legend to it, and you see what will happen. So now, this is east, west, and north. So we can look at the rainfall pattern in the eastern region, in the western region, in the northern region, in the month of July, in the month of June. So we can say in the month of July, we had much more rain in the northern parts as compared to the eastern parts. And that's how it is. You can interpret this graph the way you want. Any issue with a stack bar plot. The legend to top left, top right, that one, you know it. Then that's the sizes of these bars. The size of this bar, the fill to the same colors. And that's how that one works. Now, the very last one we have just 3 minutes, is a box plot. Box plot is a very interesting plot. It's used by many scientists everywhere. Box plots is very, very useful. So now for box plots, you must have a wider data point. Because of that, I couldn't build it. I couldn't build that one. So I had to look for pages and how to things on. So this empty cast. But you see that if I put square bracket by it. If I do like this, I'm looking for columns and the rows. So if I go to the column side, it's the same thing I have done here. So on the column side, I'm just looking for just 2 of the columns, leaving but all the rows. So I'm looking for the MPG and the cylinder, dimensions. So I pack that into this variable called inputs. So I come and use a box plot. This is the syntax for box plot. So these are the 2 data points that we are looking at. So we are looking at all the way to the income, and then the data is coming from empty cast. You have your X label in miles, and then the main is mileage per data. The main is always the title. When you do that, if I start running that, you can see my box plot over there. So the box plot come here with all the labels, Y label, X label, then the main will give you the title here. But see, there's no color. So I could actually add color, just like the way we created the colors first. So in this case, how many box plots do we have? We have just 3 of them. So the color should be according to. And then we could so I created the X label, which is already here, the Y label, which is already here, main, that's already there. The only thing I've added here is a notch. The notch means, do you want it to appear like, these are boxes. But what about if you want it to appear like a violin? You see? So you could actually indicate that there. So sometimes you can say a notch. The notch means it's going to appear, it's a constricted way of appearing. So if I run that again, you see that that side, you can see that that particular, see how what they look like. They look quite, this is the notch that I was talking about. If we are going to do real data visualization, where I'll be using ggplot, I don't know. My computer has just. Hello?
Yeah, we can hear.
Hi, we are here.
I can't see anything. Okay, now it's coming. I don't know what happened. My computer just went off like that. Hey, seriously? Okay. So that is box plot for you. Is when we start ggplot, in fact, we would be interpreting the results. Like when you see a box plot like this, how do you interpret this? I think it's part of the job we'll be doing. Now histogram, that one is quite simple. Histogram is quite simple. You just have your histogram, the name, your X label, Y label, the color, and whatsoever. If I let me just put everything around it at once, so you can see your histogram there. Look at how it looks. All those decorations, they are what a line graph. Line graph, you indicate the type of the line. You can actually add another line. So this is a line graph. So I could actually add another line. So this line now become color. I've added color to it. You add another line to it. If I do that, another line will come to it. And so now I'm dealing with two data sets, so I can interpret them and see how they interact. And then you see that my line graph is here. And of course, if I were to do a scatter plot of the the cars that I spoke about, this is a scatter plot. You can add a trend line to it. You can add trend line, but this is the last one. Please, this is the last one. This part is where you actually would want to. This scatter plot, you are just looking at how the data points are distributed, but you haven't actually looked at the interactions of how one or two things are. So, for instance, I have the WT, that's the weight. I have the MPG of the cars. I have the piston displacement. I have the cylinder size. So I want to see how each of them are interacting. How does this function called pairs? And then when we run it, you will see that we are able to see how they interact. You can see the way the data they interact. So we can interpret each of them. This is the weight, and then the MPG. Look at how. So there's a negative correlation. Here you can see there's a positive upward sloping. This one is sloping downward, and we can interpret them each by. That's how it is. I was just about adding color to it when we came online, so I couldn't send all the codes to you for you to try. I think that's basically all that we needed to do today. But this one we just did it because tomorrow we are going to be looking at the statistics of R. And so some of this plot will come up, and it's important for us to have prior knowledge as to be able to visualize the data. That's why I just did this once. But real data visualization is ggplot. It's a whole book by itself that we're going to do. We'll learn ggplot from scratch, so that we can actually, you will see that the graphs are different. This one, they are not nice. When you use ggplot to generate a plot or to visualize your data, that's where we can see evolution, trees, and whatsoever, models and stuff. See how model is behaving. In fact, we can generate a plot that is live. Is working. You are putting the data, and then the graph is changing by itself. Live. So this one there, just. Any question so far? I'm sorry that some people some hitches.
Interesting.
Yeah.
There's one bit about my R.
Yeah.
You see where you have the fourth quadrant, where we have the packages.
Yeah.
So I realized that whenever I have my plot, it comes as a pop-up, but it's not located in that particular quadrant.
Like the plot doesn't appear here like the way it appears.
Yes, but rather comes as a pop-up. I don't know if Pauline also have the same thing.
Paulina, do you have the same issue?
Where?
This this particular quadrant. When you generate your plot, does it appear like this?
Which side are you
take a video
for it to see.
I'm saying, if you generate your this thing,
Yeah.
your plot, do you see it here like the way I'm seeing mine?
Yes.
Okay. Yours, as you are saying, I'm a little bit.
Check whether
So,
he hasn't
this-
closed, like mesh some of the this. I don't know. Check the
this is what I'm talking about.
Okay, let me see.
So my contract is here, but the pop-up is down. I'm trying to get it out. I don't know if you can see down there. I have the
Yeah,
pop-up.
I can see it.
So when I press it, then it comes up.
Okay. I think I will check that again. Maybe it's about the settings, the display settings. I don't think it's a problem. Yeah. I'll check the settings, and I'll get it the correct answer for you.
Okay.
So so what is it? I will modernize all the codes, add some kind of descriptions to them, and then I'll send it to all of you before I sleep. When you have generated your plot, I was expecting that one of you asked me a question as, so how do we get this plot out of here? You can see exports. So you can save it as an image. When you click on export, you can save it as an image. You can save it as a PDF. You can copy it to your clipboard. You can copy it and go and paste it on your Microsoft Word, or you can save it as an image and use it later, or PDF and use it later. All the plots, that's what happened. Okay. So without much, I'll say we'll leave it here, and God willing, we'll meet tomorrow.
Thank you so much.
You're welcome.
Thank you.
You're welcome.